Hi, today we are going to learn lossless decomposition. If there is a relation schema R and you decompose this relation schema R into R1, R2 up to Rn subschema. So how will you find this decomposition is lossless? So method is, if you perform natural join of all subschema produces exactly same relation R, then lossless decomposition is performed. Otherwise, lossy decomposition. So lossless decomposition, it is good, it is not good. So how we will determine a decomposition is lossless? The method of finding a decomposition is lossless is, for example, there is a relation schema R has 5 attributes A, B, C, D, E, and its functional dependency is AB functionally determines C, C determines E, B determines D, and E determines A. There is two decomposition of relation schema R and created subschema R1 and R2. R1 has attribute B, C, D, and R2 has a attribute A, C, E. Now we have to determine where this decomposition is lossless or lossy. The method is, there is one variable we will take as a distinguishable variable alpha, and we will fill this table with alpha. There is two subschema R1 and R2 and 5 attributes are there, so we have created a table according to 5 attributes. R1 has an attribute B, C, D. R1 has B, C, D. That's why we have filled alpha with R1 on B, C, and D. R2 has A, C, E. A, C, and E. Now, if we are able to add alpha in one row, at least in one row, trying to get one row filled with alpha. This is our aim. If we will get at least one row filled with alpha, then we can say this subschema can produce after natural join of all these two subschema produces exactly same relation R. So how we can add alpha at this blank position? The method is, first you have to check where two or more rows have alpha at left hand side of functional dependency. Here we have taken one example. A, B, 2 attributes are there and 3 subschemas, and we have to find where this is lossless or not. To apply this method, we have to check 1, 2, 3 row places we have alpha on left hand side, and we have to fill this right hand side. The 2 or more rows have alpha at least at left hand side of functional dependency. So here we have 3 alpha. It means first rule is correct. Second, 1 or more rows have alpha at right hand side of functional dependency. So right side of functional dependency, there should be at least 1 or more alpha. So it is there. So second rule is also okay. At least one row has a non-alpha at right hand side of functional dependency. So here we can see there is 2 rows where alpha is not there, and these 2 rows we have to fill. If all 3 rules follows, we can fill alpha at the blank places. So at left hand side 2 alpha is there, 2 or more alpha is there. Right hand side at least 1 alpha is there, so we can fill this remaining blank spaces with alpha. So if one row is completely filled with alpha, so it is lossless. Similarly, for this example, we have to fill according to this functional dependency. We have filled here alpha according to A derived B functional dependency, because we had checked A and filled B. Start with AB. AB combinedly, does it have 2 or more rows alpha at left hand side? No. So we can't fill C. C is already filled there. C does not follow the third rule also. C determines E. For C, if we check 2 or more rows, first rule, yeah, it follows. Second rule, 1 or more rows have alpha at right hand side. For C and E, yes, 1 alpha is there. And third, 1 blank position is also there. So we can fill this blank position with alpha according to C determines E. Now check for B determines D. B, this is left hand side, it does not have 2 or more rows, so we discard it. Now let's check E determines A. E determines A. E has 2 or more alpha. Yes, after filling it, it has 2 or more alpha. Now on this side, E is left, A is right, because E determines A. E is left, A is right. Second rule, 1 or more should be alpha there, and third rule is 1 should be blank, so we can fill it alpha. So here we can check 1 row is completely filled with alpha. That's why it is a lossless decomposition. So this is simple rule. You have to check for left hand side and right hand side. According to these rules, we can add alpha at the blank position, and if 1 row is filled with alpha, we can say it is a lossless decomposition. Thank you.